All right, Kim, let's talk about what happens when a compound does start with H+. So I know you've all been dying to know, but when you start at this first box and it says, does the compound start with H+, not including H2O or H2O2. H2O is water, and H2O2 is hydrogen peroxide, or dihydrogen monoxide for water. But both of those do not count as starting with H+ for these rules. So let me start with our most common example. You guys might have heard of this compound before. So we start at the top. It says, does the compound start with H+? H has to be in the very first position. In this case, we're going to answer yes. That means we're finally going to this side of the flowchart. Then it says, then it's an acid. Is it an oxyanion? Well, what that means is an oxyanion has oxygen in it. So you're going to see that this has hydrogen and it has chlorine. So it does not have oxygen. So we're going to go down the no road. Then it says hydro plus stem of anion plus IC acid. So you actually write the letters hydro down. And then it says stem of anion. The anion is chlorine, so the stem is CHLOR. And then IC acid. So it's hydro, IC acid with every one of them, and then you're going to stick the stem in there. So hydrochloric acid. This is a binary acid. Hydro does not refer to the fact that there's hydrogen in there. Hydro refers to the fact that there's no oxygen. So let's go through an entire series. So this compound starts with H+, so it is an acid. Is it an oxyanion? Well, this one does have oxygen in it, so I'm going to go down the yes route. It says, identify the polyatomic ion. All you have to do is put your finger over the H in this case. And the rest of it, so once you cover up all the H's, the rest of it is going to be your polyatomic ion. So we're going to look up ClO, or we can recognize that this is the least amount of oxygen we can have. So this is going to be, the polyatomic ion here is hypochlorite. So you can see my two choices are, does it have an ATE ending or does it have an ITE ending? So when you go down the ITE ending, it says change the ending to OUS acid. So we're going to take off the ITE and change it to OUS acid. So this is hypochlorous acid. That's the name. There's a difference between hypo and hydro. A very big difference, so don't forget to pay attention to that. Let's do the next in the series, which would be HClO2. It does start with H+, therefore it is an acid. It is an oxyanion. It's got oxygen in it. So next thing I'm going to do is cover up the H, and I'm going to find this polyatomic ion in my list of polyatomic ions. This is chlorite. Again, ends in OUS, so this is going to be changed. Ends in ITE, so it's going to be changed to OUS acid. So this is chlorous acid. Let's do the next in this series, which would be HClO3. Remember, Chlorine is on the outside, so ClO3 is chlorate. That's the most common polyatomic ion in this series. So this is chlorate. Now we have an ATE polyatomic ion ending. So let's go on the ATE. It says change the ending. So we're going to change that ATE to IC acid. So this is chloric acid. Let's just do the last in this series, which is HClO4. So that's one more than chlorate, so that is perchlorate. We'll change the ending to IC acid, so this is perchloric acid, like such. So this is a series of polyatomic ions and the acids that they become when you make a bond with H+. Let's do a few more acids with maybe some polyatomic ions that aren't in one of those series. So how about this guy? It does start with H+, so it is an acid, and I can still do the same thing. I can still put my finger over the H, cover that up, and whatever's left over is my polyatomic ion. This polyatomic ion does have oxygen in it, so we're going to find it in its acetate. That polyatomic ion ends in ATE, so this is going to become acetic acid. This is the active ingredient in vinegar. Let's see, how about again, starts with H+, so it's an acid. It does have oxygen, so that's an oxyanion, and you're going to find it in the list of polyatomic ions, and this is going to be chromate. So we're going to change the ATE version to IC acid, chromic acid. So let's summarize. We have three types of acids. We have binary acids, and we have ternary acids. So hydro and then IC acid is an acid with no oxygen. What I'm going to see is you guys are going to want to throw this hydro around. You're going to see that something starts with H and you're going to think, oh, I've got to tell you that it's hydro. No, you don't. The word acid tells us it starts with H+. So hydro means there's no oxygen in the compound. So that's our binary acids, mostly. There's a couple exceptions. So this is hydrochloric acid, hydrobromic acid, hydroiodic acid, hydrosulfuric acid, hydrophosphoric acid. So there's not that many of them. When H+ is with nitrogen, it actually becomes ammonia, which is not an acid. It's a base. When H+ is with carbon, it becomes NH4, which is methane, which is also not a base. So there's not that many of these acids. Here's one, too, hydroselenic acid. So the hydros are not going to tell you that it starts with H+. The word acid tells you it starts with H+. The word hydro tells you there's no oxygen. Then we have ATE polyatomic ions end in IC acid. These do have oxygen in them. They don't use the word hydro. So that's any of the polyatomic ions that end in ATE, such as nitrate. This is nitric acid, carbonic acid, so on and so forth. Sulfuric acid. Those are examples. Notice that they start with H+, but I don't use the word hydro. And then we have the ITE polyatomic ions. Those are going to be changed to OUS acids. So we only have 3 types of acids. Either there's no oxygen and it's hydro-IC. It has oxygen in the polyatomic ions in ATE. It's IC acid. It has oxygen in the polyatomic ion ends in ITE. We change that to OUS acid. So examples of that would be chlorous acid, carbonous acid, sulfurous acid, like such. So here's a summary of our 3 different types of acids. You now know how to name all of the compounds on this flowchart.